Point clouds can often be used in particle simulations in order to direct particles and use some outside geometry to influence the way that particles work. Now, while it might be outside of the scope of this tutorial to do a full particle lesson, I'm going to show you, at least for those of you that are familiar with particles, how you can use some point clouds and influence your motion there. So we'll do some very basic stuff here. I'm just starting with a new geo here. And we will just use a grid as our particle emitter, and we'll make this pretty small, something like 0.1 by 0.1. I'm going to go to my front viewport here. What we're going to do is just draw a curve, and we're going to use this curve to influence the particles. So I'm going to try to get that first point kind of close to the origin here. And we'll just draw something like a nice little curve shape like that. And then I'm just going to take a couple of the points and we'll just kind of break the axis here so that we've got some motion going in a few different axes here. All right, something like that seems to work. I'm going to make that a NURBS curve, and then what I'm going to do is resample so that we have a lot of points to work with. And then we'll take the length, make that something like 0.1. So now we have a lot of points to work with, and what I'm going to do is make normals that are going to align along the curve here. And to do that, we will use a polyframe. Just place that down like that. And then I'm going to use N. And then I want to reverse these. So I'm just going to make an attribute wrangle. And we'll just say at N times equals -1. Now I'm just going to make a null, and we will call that curve geo. All right, that's my emitter. So now we'll make a pop network. Wire the grid into the first, and then second input will be the curve geo here. I'm going to select the source. I'm just turning my guide off. And then for birth, why don't we change this to 500? And we'll say 0 velocity. Okay, so if we were to just play this, the particles are just born, but they don't do anything. So why don't we go ahead and we'll start using the points from that curve and the surface normals to move these particles. So I'm going to use a pop wrangle for that. Sorry, not pop wrangle. I wanted the pop vop. We just wire that right in here. Then for inputs, for input number 2, I'm going to want the second context geometry. And that means give me this input here. Now going back into here, what we're going to do is do a point cloud lookup. So again, just like before, we need a point cloud open. We want position for our lookup position. The file is going to be our second input. And then we will promote radius and we will promote max points. And now we are going to use a filter. So point cloud filter. And I want to grab the normals here. So I'm going to take those normals and normalize them just to make sure that they are a unit vector. And this is going to end up being velocity. What I want to do is give us a control here. So I want to give us something we can scale that by. So I'm taking a multiply, and I'm just going to grab a parameter here. We can call this N scale. I'll just call that normal scale. Give that a default value of 1. and add that straight into velocity here. So our search radius, we can bump that up maybe to 1. Number of points, why don't we go with something like 3, and we'll just keep that as is. And now we can see that if I template that curve here, that we're attempting to move along the curve. Now we might be moving a little bit too fast here, so why don't we just bring that down. Let's see if we can conform a little tighter to the curve. Otherwise we would need to substep a little bit more. But here, if we just slow the motion down, we can see that we actually are conforming to the curve. So that's pretty neat. And there's a couple other things that we could do if we wanted to. We could make an attractive force, or we could make a rotating force. So to do that, why don't we actually find the position. And then what we'll need to do is take a cross product of the normal direction and our current point position, or the vector actually pointing from our point position to the curve. So we need a vector actually that points from the particle to the curve. So what we'll do is subtract this position from that position there. And again, I'm going to normalize that. And then we have our normal direction here. And now if I cross these, we are going to get a perpendicular vector. And again, we will multiply this by a parameter so that we can scale it. And we will call this rotation. We'll give that a default value of 1. And then we will add these together here. Then go straight into velocity. And we'll just reset. So now why don't we make these kind of equal here. And now you see what happens is that we have these particles that are moving along the normals, but they're also spinning as they do that. And we could continue to refine this as much as we want. Then if we wanted to make an attractive force to the curve as well, we just need to take this value here, which is the vector that is pointing to the curve, and it's already been normalized. And then we could add that in here as well. So I could just multiply this value here by a parameter. And we'll call this attract. Default that to 1 as well. And just add that back in. And I'm just going to give this a small value. Maybe even smaller. And you can see that the particles then become attracted to the curve. So we're doing all of this just by using distance lookups. And we could get smoother results or more accurate results just by saying we only want 1. I typically never use 1 in this setup because you can get some kind of jagged motion here. So I'm usually at like somewhere between 3 to 4, depending on how many points I actually have on the curve or how many points I have that I'm sampling from or want to sample from. It's kind of a nice general setup. And the cool thing about this is that you can actually start to add some other forces in here. So we could add something like a pop force and just give us some noise here. Maybe a small swirl size. Get some kind of nice, interesting dynamic results. Maybe I'll just go ahead and go back to our birth tab and we'll just do 5,000 so that we have a lot of points to work with. And then I'll just change my geometry here to pixels so that we can kind of get a better sense of what's happening here. So this is one technique that I use a lot for directing particle simulations, and it's all point clouds, as you see. So it's a pretty handy tool to get to know, and as you'll find out as you work more and more with point clouds, you'll see that it's really handy to know how to use those functions, and they're not terribly complicated to use, luckily for us.